Hey guys, welcome to my channel. So in this channel, we're going to be talking about physics. I'm going to try my possible best to break down physics topics into very simple terms so that we all can understand it. So if provincial physics is an issue for you, you can stick around and enjoy this wonderful journey with us. So for today, we're going to be talking about one of the very first topics in physics, which are physical quantities. I know we've had a lot physical quantities and all of that. So let's dive into it, what physical quantities really means. So physical quantities are measurable properties of matter. Measurable properties of matter. For example, you want to measure something, let's say your rice now. If you want to measure it, you can measure it in cups. Yeah, so at that point, measuring a cups is like the physical quantity of that particular rice. So that's how it is. The same physical quantity cannot apply for every other thing. Every other thing in matter is measured in different physical quantities. Examples of physical quantities in which matters are being measured in are length, your time, your mass, and even your velocity, etc. So, physical quantities are actually grouped into two major groups, and those groups are the derived and the fundamental quantities. Let's start from the fundamental quantities. The fundamental quantities are the basic quantities that are independent of others and cannot be defined in terms of other quantities. In other words, they are quantities that can stand on their own. They are independent on their own. They don't need any other quantity to define or complete them. And example of all those quantities are your length. Your length, the unit for length is meter, and the short form for meter is your simple m. We also have the mass. The unit for mass is kilogram, and the abbreviation is kg. We have the unit for time. We all know that one is called seconds, and the short form for seconds is s. Then we have the unit for electric current, which is your ampere, and the short form for ampere is a. We also have temperature. Temperature is measured in um Kelvin. So, and the short form for Kelvin is K. We also have for amount of substances, which is mole. Mole, the short form of mole is MOL. And luminous intensity is measured in chandela. Some people call it candela, candela, whatever. It's spelled this way, candela, and the short form is CD. So these units are the basic units in physics. They are able to stand on their own, they are not defined in terms of other units and all of that. So let's move on to your derived units. Your derived quantities, rather, are the basic units that are obtained from simple combination of the fundamental quantities. Sorry, let me adjust this. So I go again. These are units that are obtained from a simple combination of fundamental quantities. So the derived quantities cannot stand on their own. They are dependent on the fundamental quantities. Look at the term derived, fundamental. These ones are derived from fundamental. Fundamental are basic. So for you to be able to acquire the derived unit um for you to be able to obtain the derived unit of any quantity, you have to follow these various steps. And these steps are: one, write the defining equation. Defining equation is like what a particular term is represented as. For example, now your force if you want to calculate for force is being measured as mass times acceleration. So that is like the defining equation. Instead of you to start writing all manner of long terms to define what force is all about, you can just represent it with a simple formula, and that is what you're defining, and that would be is the defining equation for force. So next step is to expand the expression in terms of the fundamental quantities that make up the derived quantity. I take it again. Expand the expression in terms of the fundamental quantities that make up the derived quantity. So what this basically mean is that you expand the equation in which you've written down, your defining equation. You expand it in terms of its fundamental quantities that makes it up. Then the third step is that you state separately the units of all the fundamental quantities. Now you've written down the fundamental quantities that make up the defining equation. The next step is for you to state the units of that particular quantity. So that will take us to our fourth step. The fourth step is to combine the units as the quantities are combined in the expanded expression. If you've stated out the units, you will have to put the units back in terms of what the defining equation. Write it back like you are writing the equation, but this time you use the units that are being represented to write down the equation, which will take us to the fifth step. Reduce the expression to its lowest term. So what you basically do is to cancel out anything that's repeating twice and all of that, just to reduce it to its lowest term. And then the sixth step is to write the resulting expression in its index form. Yeah, that is so. These are basically the steps that are needed to be able to obtain your derived quantities. So in my next video, I'm actually going to give out practical examples on what you can do, on how you can apply these steps in your equation. So bye, take care for now. Don't forget to like and subscribe to my channel.